Hey friends, so today is lesson 3 of our trigonometry unit. And yesterday when I introduced lesson 2, one of the things that I said is the next 3 lessons kind of go together. So lesson 2, lesson 3, lesson 4. And here's why I said that. So in lesson 1, the second half of lesson 1, we kind of introduced this concept of angles in standard position. Yesterday was all about getting exact value of trig ratios, but it was based on angles that would come from special triangles. Okay, we had our 30, 60, 90 degree triangle, and we had our 45, 45, 90 degree triangle. Now today, we're going to look at exact value ratios, but they're going to be generated not from special triangles necessarily, but rather from knowing a point that's on the terminal arm. Remember, we said that the initial arm starts on the positive x-axis, and then we rotate towards the terminal arm. Well, if I put a point on that terminal arm, and I drop a perpendicular from that point, that's going to create a triangle for us where I know the base and the height of that triangle, because I have to get to that point, right? So using the base and the height, I can solve for the hypotenuse, and then I can get exact value trigonometric ratios based on that non-special triangle, okay? So that's kind of where we're going today. All right, so how do we find sine, cosine, and tangent of an angle that is larger than 90 degrees? How do we define the sine, cosine, and tangent of a negative angle? That's sort of the things we're going to talk about today. We need to make a new definition for sine, cosine, and tangent. The new definition involves a point on the terminal arm. So we're going to call that point P, and we're going to label it as x, comma, y. And its distance from the origin, r. So the hypotenuse essentially is going to be labeled r. Now, for those of you who are at home who don't have my notes in front of you, here is that slide just so that you can see everything going on there. All right. So when a point P, x, comma, y is connected to the origin 0, 0, it defines an angle in standard position. So we're going to draw a picture of that. Okay. Again, I'm just going to hide myself for one quick second so everybody can see the question. All right. So something like this. This looks really similar to what I did with you yesterday, right? The only difference is now I'm labeling the hypotenuse r. Here's the thing. If I have this point, x, comma, y, in order to get to that point, I had to go over x and up y. So I can label this bottom distance x, and I can label this height y. Okay, so if a vertical line is drawn from point P to the x-axis, we have a right triangle, much like we did in yesterday's lesson. And I know that we're going to label this as x, label this as y. Now, some of you may be wondering why we're labeling the hypotenuse as r, and that comes from the word radius. When we take this information into 30-1, that hypotenuse is actually going to become the radius of a circle. But we'll define that a little bit more next year, okay? Or if you're dying to know, you can look up the unit circle video that I have on YouTube, okay? Using the Pythagorean theorem, then, we could say that x squared plus y squared equals r squared, okay? So none of that should really feel unfamiliar to you. Now, this whole lesson, though, is titled New Definitions of Trig. Well, they're not really new definitions. They're just new letters, right? If I looked at theta here, and we were looking for the sine of theta, the ratio for the opposite over the hypotenuse for theta, we would say it's the opposite over the hypotenuse. Well, the opposite is y and the hypotenuse is r. And so in all of these triangles that I built yesterday and today and tomorrow, we always have the vertex of the angle at 0, 0. Because of that, we can always label the base x, and we can always label the height the y value. And so now, instead of just saying it's opposite over hypotenuse, we can actually physically just say, oh, it's going to be the y value over the r value, okay? And for cosine, instead of just saying it's adjacent over the hypotenuse, we can say, oh, it's going to be the x value over the r value, okay? And then instead of saying tan is opposite over adjacent, we could say, oh, it's going to be y over x, okay? So that's really all we're saying when we're saying new definitions. So sine of theta is y over r, cos of theta is x over r, and tan of theta is y over x. Okay. I'm just going to hide myself for 1 second in case I am blocking you. I'm never actually quite sure if I'm blocking you or not, because where my picture is when the video is recording is not where my picture ends up. So, okay. Awesome. So let's try it. The point -4, 3 defines an angle theta in standard position. Determine sine of theta, cos of theta, and tan of theta. Okay, so the first thing I want to do is draw the point -4, 3. I know that I'm in quadrant 2 because my x value is negative and my y value is positive. So to get to that point, I have to end up in quadrant 2. So I have a terminal arm in quadrant 2. That's the first thing that you should draw for me. Okay. Now, I know the point -4, 3 exists somewhere on this terminal arm. So at some point, I'm going to drop a perpendicular. Okay. And then I'm going to label my x and my y. So I know I have a reference angle in that bottom corner, and I know that the base of my triangle is -4 and the height of my triangle is 3. Okay, so now I can use the Pythagorean theorem to get to the r value, or the hypotenuse here. Okay, so -4 squared is 16. Be careful when if you're putting that in your calculator. Remember that you have to put -4 in a set of brackets. If you just write -4 with a square sign, your calculator will give you a -16 because it knows that the negative doesn't apply unless it's in a set of brackets, okay? So if you're using your calculator to figure these out, make sure that -4 goes in its own set of brackets, okay? So -4 squared is 16, 3 squared is 9, 16 and 9 is 25. I should actually be looking at the root of 25, which is 5. So I have an r value here of 5, okay? So now I'm ready to go sine of theta, cos of theta, and tan of theta. Sine of theta is y over r, or opposite over hypotenuse, which is 3 over 5. Okay, so yesterday we got ratios based on special triangles where we put in a proportional number that represented each side of the triangle. In this lesson, we're actually using numbers based on the point that came from the terminal arm. Okay, so sine of theta is 3 over 5, cosine of theta is -4 over 5, and tan of theta is -3 over 4. We don't say 3 over -4. We don't have a negative denominator. If there's one negative on a fraction, just bring it to the front or put it on top. It doesn't matter where it is as long as it's not on the bottom. We don't like to have negative denominators. Okay. All right, good. Let's try another one. The point -6, -4 defines an angle theta in standard position. Determine sine of theta, cos of theta, tan of theta. And now I'm just going to warn you, express answers as exact values, simplified radicals. This one's going to get a little bit messier as far as the numbers go. On a test, I'm not going to warn you to express as exact values. That should be understood. The general rule for any assessment in 20-1 and 30-1 is if we don't give you rounding instructions, you're not allowed to round anything. So if we don't give you rounding instructions, you're not allowed to write it as a decimal. You have to write it as an exact value. An exact value would be a reduced fraction or a simplified radical, okay? So I know because both x and y are negative here that I have to be in quadrant 3, right? I have to get to the point -6, -4. So that puts me in quadrant 3. I'm going to drop that perpendicular, and I know that the base of my triangle up here on the x will be -6, and the height of my triangle, the distance of the y, will be -4. I need to use the Pythagorean theorem, just like in the last example. I need to use the Pythagorean theorem to get to the hypotenuse. -6 squared is 36. 4 squared, -4 squared is 16. When I add 36 and 16 together, I get 52. So I'm looking at the root of 52. The root of 52 can be simplified because it's 4 times 13. So the root 4 becomes a 2, and I'll be left with 2 root 13. Okay, I'm just going to hide myself right quick in case you can't see all of that. All right. So now I know all the sides of my triangle. I'm ready to start saying sine of theta, cos of theta, tan of theta. So sine of theta, remember I'm basing it off the reference angle because that's where my 90-degree triangle is, right? So sine of theta would be y over r, or opposite over hypotenuse. So that's -4 over 2 root 13. Now, 4 over 2 will simplify to 2, but I also want to rationalize that. So I'll multiply it by root 13 over root 13. And that's going to give me a final answer of -2 root 13 over 13. Okay, -2 root 13 over 13. For cos of theta, I'm going to be adjacent over hypotenuse, or x over r. So that'd be -6 over 2 root 13. -6 divided by 2 is -3. So I'm looking at -3 over root 13. But again, I want to rationalize that. So that'll be -3 root 13 over 13. And then tan, well, tan of theta is opposite over adjacent, or y over x. So that'd be -4 over -6, but that actually reduces to +2 over 3. Okay, +2 over 3. Awesome. Okay, hoping this is feeling okay. If it's not, keep going, right? Keep practicing. Watch this again. Ask me questions, okay? Don't ever feel confused. I want you to feel comfortable with what's going on. I know you can do this, okay? It's just a different way of looking at things. Okay, the point k, 12 is 15 units from the origin. If P lies on the terminal arm of an angle theta in standard position, and theta is somewhere between 0 and 360 degrees, that's what that says there, determine the following. Okay, so the first thing we want is the measures of angle theta to the nearest hundredth of a degree. Okay, all right, well, the first thing I need you to see is, I just said it was k. I didn't tell you what the x value was, essentially, right? But I know my y value is positive. Well, if my y value is positive, that's going to put me in either quadrant 1 with a positive k value, or that's going to put me in quadrant 2 with a negative k value. Okay, so there's actually going to be two answers for this. One where my angle in standard position exists in quadrant 1, and one where my angle in standard position exists in quadrant 2. Okay, 15 units from the origin, that's going to actually be the hypotenuse of my triangle. So let's draw a picture. Something like this. So here is my first example, and then I have one for my second example as well. Okay, so this is where I'm at. Now, I'm looking for the measures of angle theta at the moment. Well, in order to get theta, I need 2 of my 3 sides, and I have 2 of my 3 sides. I have the opposite, and I have the hypotenuse, or rather, you could say I have the y value, and I have the r value, right? Okay, so who uses opposite and hypotenuse? Well, that's sine. So I can actually say that the sine of theta is 12 over 15. Okay, sine of theta is 12 over 15. You will recall that to get to an angle, I now have to arc sine that, or inverse sine that. Okay, so we'll say theta equals the inverse sine of 12 over 15. I just reduced my 12 over 15 to get my 4 over 5. And then that's going to give me 53.13 degrees. Now, it's said to the nearest hundredth of a degree, right? So make sure you're following rounding instructions. Don't follow rounding errors. Okay, so that ends up being my reference angle, okay? That 53 degrees, I could stick right here, or I could stick right here, okay? So one of my answers is for sure 53.13 degrees, because that's the one for quadrant 1. The guy for quadrant 2, though, because that could be a reference angle, my other quadrant 2 answer will actually be 180, right? All the way over to here is 180. Minus that reference angle will give me what I want. Okay, so my second value for theta could be 180 degrees minus 53.13 degrees. Okay, awesome. Now that will be 126.87 degrees. And we're going to go to the next section, which is the exact sine, cosine, and tangent ratios for theta. Now, in order to do that, I need my k value. Okay, so to get my k value, I'm just going to use the Pythagorean theorem, remembering that when I get k, I know that k could either be positive in the first quadrant or negative in the second quadrant. Okay, so I end up with 15 squared equals 12 squared plus k squared. 12 squared is 144, 15 squared is 225. Subtract 144 from both sides. I get k squared equals 81. So k is plus or minus 9. Okay. Okay, so I need the exact values from quadrant 1 and the exact values from quadrant 2. So I'm just going to list the 3 for quadrant 1 and the 3 for quadrant 2. Okay, so in quadrant 1, sine of theta would be 12 over 15, cos of theta would be 9 over 15, and tan of theta would be 12 over 9, and you're going to want to reduce each one of those. In the second quadrant, sine of theta would be 12 over 15, cos of theta, though, would be negative 9 over 15, and tan of theta would be negative 12 over 9. Okay, so sine theta 1 is 4 over 5, sine theta 2 is 4 over 5. Okay. Cos of theta 1 is 3 over 5, but cos of theta 2 is negative 3 over 5, because in quadrant 2, that k value is negative. Okay. And then tan of theta 1 is 4 over 3. This is exactly what I just said, right? I have them reduced for you. And then tan of theta 2 is negative 4 over 3. Okay? You get this. Okay. So that's where we stop for today. If you are one of my kids at school, here is your homework from your workbook. If you're not one of my kids at school and you're just along for the ride, by the way, I'm glad to have you, first of all, if you're just along for the ride. And second of all, I'm sure you can get lots of different practice from your school or from different websites, but do try to practice this as much as possible so that you can get a good understanding and you can feel confident about this. I really want you guys to feel confident about this stuff. And for those of you heading to 30-1, these, these 3-4 lessons that we're doing right now, all around angles and standard position, if you can get a really good grasp on this in grade 11, it will so help you in 30-1. Okay, so take the time to feel good about this stuff. Okay, give yourself the time to practice, give yourself the time to process, and give yourself the time to ask questions. You know where to find me if you have any questions. Okay, awesome job, guys. I'll see you for the next lesson. Take care.